Hey everybody, it's Joel Irway with dailyfeexamprep.com, and welcome to video number 2 of the user request section for engineering economics, nominal versus effective interest rates. If you didn't watch my first one, please watch my introductory video where I discuss the difference between nominal and effective interest rates. Now we're going to go solve an example in this one that Chris has sent me. Chris is part of my FE Focus Formula accountability group, and what I offer for everybody who's in the accountability group, I offer them this option to have me solve these problems for you in a video format. So Chris sent me this problem because he's having trouble understanding the difference between nominal and effective interest rates. So what I'm going to do is he sent me this problem, and I will go through and solve it for you and explain it. So here is the question. So $5,000 is put into an empty savings account with a nominal interest rate of 5%. No other contributions are made to the account. With monthly compounding, approximately how much interest will have been earned after 5 years? So there's a couple things that I want you to notice here. The most important one is that we have a present value of $5,000 put into a savings account that with no future contributions that will be made. Now that's very, very important because that is going to define the formula for which we calculate our future earnings. Now the next thing I want you to notice is that they give us the nominal interest rate of 5%. And if you remember in the previous video, I told you that the nominal interest rate is usually going to be a round number because it's easier for us to comprehend, and it's much simpler for the people who are lending the amount or who are giving you that interest rate. So the nominal interest rate of 5%. Okay, the first thing that we need to do though is we need to convert that nominal interest rate into an effective interest rate because this is going to be compounded monthly. So when it's compounded, this nominal interest rate is not going to be the actual interest rate for which we are going to be using because it's going to be compounded into monthly terms. So the first thing that we need to do is we need to convert that to an effective interest rate, and we know that the formula is shown on. Let's go ahead and get this up here. Page 127. Of the NCEES Supplied Reference Handbook, version 9.2. Okay, so when we are calculating out an effective interest rate, which is non-annual, okay, because if it's an annually compounded interest rate, then your annual compounding interest rate will equal your nominal interest rate. But since this is non-annual, it's compounded monthly, we need to calculate that effective interest rate. So it's 1 plus R divided by M, so which is your nominal annual interest rate, divided by the number of compounding periods per year, raised to that same number of compounding periods per year, minus 1. Okay, so let's go ahead and calculate out our effective interest rate. So we've got I sub E is equal to 1 plus R over M raised to the M minus 1, which equals 1 plus 0.05, which is our nominal value, divided by 12 months out of the year. That's how many times we're going to be compounding it, raised to the 12 minus 1. And when you calculate that out, you get an effective interest rate of 0.05116, which equals 5.116% of an annual effective interest rate. Okay, so that is our effective annual interest rate. So that's the real value of what we're actually going to be earning over the course of these compounding periods. Okay, so now what we need to do is we've got that rate, so let's go ahead and hide that. But we need to find out how much interest is earned after 5 years, and we know that no other contributions are going to be made. So what we're going to find, how much interest earned after 5 years. So when you're trying to calculate out your future value, we have tables, we have formulas given to us on that same page. Okay, so this is a very, very simple conversion. There are no additional contributions. So we want to find our future value. Okay, we know future value is, or future worth is defined as term F, and we already have a present value. Our present value is $5,000. That's how much we've put into the bank account. So the $5,000 is the amount that we put into the bank account, and we're just going to let it sit there. We're letting it sit there, and it's going to be a very, very simple earnings. Because we're not adding any additional value, this is how I know how to define, how to know which factor name to use. Since I'm not adding any more contributions, this is just a single payment compound amount. When I hear single payment, I think of a simple formula, and if I look at the most simple formula here on the chart, this one looks pretty simple to me. 1 plus our effective interest rate times the number of compounding periods. Okay, so this is the formula that we're going to be using. We want to convert our present value to our future value here, given the present value. Okay, so F is going to equal P, which is our present value, times this formula here. Okay, so now if you want to kind of like understand the math behind it, because they don't tell you to actually multiply P here, but you're always going to need to multiply whatever this given value is to the top of this formula, or to the start of this formula. You're always going to need to do that. But your symbol here is basically how the math is going to work out is P times this F over P. So you're basically getting rid of the P and you're getting this F. Okay, so I might have confused you. If I did, just forget about it. But just understand that you always have to add this variable to this formula. So you're always multiplying those two to get this number. So that's what we're going to do. Okay, so we want to convert our present value to the future value. So we have F is equal to P times 1 plus our effective interest rate raised to the number of compounding periods, which equals $5,000 times 1 plus 0.05116 raised to the number 5. Okay, so do you know why we're doing 5 there? It's because we converted these two numbers here, okay? Your effective rate and your number of compounding periods always have to match. We converted in the previous step, we converted this number into our effective annual interest rate, okay? And we know that our annual, we're going to compound it 5 times annually. Now you can do the same thing. You can even calculate your effective monthly interest rate. Now if you calculated your effective monthly interest rate, then this number up here is going to be 60, because you are compounding that monthly 60 times, and you're going to get the same answer, or at least a very, very, very close answer. But because we converted this into an effective annual interest rate, we need to compound it by the number of years. So that's why this number is 5. And when you multiply that out, we get a total value of $6,417. Now, the question is asking us, how much interest have we earned? Well, the interest that we earned is this total future value, $6,417, minus the present value of $5,000. So the total interest that we earned was $1,417 after 5 years. So that's the answer to this question. Okay, we're going to go through one more example. So if you still are having a hard time comprehending this, I will be giving you another one, so be sure to be on the lookout for it, or I'll probably just have a link to it at the end of this video. So if you're interested in joining the FE Focus Formula Accountability Program, I will give you a link below. Otherwise, stay tuned for the next video. Thanks for watching.